Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. In mathematics, where were we? We were at the end of the 8.1 exercise. We have started probability for quite a few days, and we were at the third question of exercise 8.1. So I have to record three lectures of physics in a row to complete that the first chapter of the physics. So this is your book, my dear students. Okay. Now let me start with the question number 4. Now, in fact, we have done three questions. Question number 4. Question number 4 says research shows that probability of a person being right-handed is 0.77. Now, question number 4, exercise is 8.1, probability. And now, question number 4 says that right-handed persons are how many? 0.77. Now, this is the probability. Okay, you can say it at P. Right-handed is equal to 0.77. Okay. Now, how many left-handed people should you accept in the population? Now, N is your population is equal to 25,000 persons. Okay. You should write the data before you go into the detail. And what you have to find is you have to find P of this is right-handed. You have to find left-handed. What you have to find is left-handed. Left-handed. Okay. That should be equal to the probability 1 minus the probability of the event. Now, this is not the probability which is given to us. Okay, I told you about the probability of not, that is equal to 1 minus a. So, similarly, you see that this probability, we know this probability, that is 0.77. So, 0.77, it will become 0.23. The probability of not having right-handed. You cannot say, for instance, you cannot say it that these are the left-handed. Okay, so when we say it that the probability of right-handed is 0.77, of course it does mean the only other hand available to human being is left hand. So now you can say it probability of left hand. Okay, now you can say it probability of left hand is 1 minus 0.77 because the total probability always remains 1. The total probability of the event always remains 1. So 1 minus 0.77 which is given to you will be equal to 0.23, which is the probability of not in the event. So the not in the event is of course the other hand available to the human being is probability of left-handed. So probability of left-handed is 0.23 and the population is 25,000 persons. So it is asked that how many are the left-handed persons. The question here is how many are the left-handed persons is equal to this. Okay, so it is simple that you just multiply this figure with 25,000. Okay, just multiply this with 25,000. You will get what you get is 0.23 multiplied by 25,000 equals to, that is equal to 5,750 persons which are left-handed. left-handed person. Left-handed person. Okay. I am not in this. I am in this. Okay, category. Now 5,750 was the answer. Now after this, question number 5 is waiting for us. Now there is a flower enthusiast, which collects the flowers, and he has collected 385 examples of. Now he has collected 385 samples of what the the name of the flower is in given in botanical terms, Polynomialus mathematicus. Polynomialus mathematicus flower in the deepest Peru. Just 5 of the flowers were blue. So Polynomialus mathematicus flowers. Okay. PMF, I am writing its short form. So only one flower is chosen at random. Just 5 flowers were blue. Okay. Blue flowers. Among these were 5. Okay. Now you see that only he has collected PMF is equal to 385. But in these 385, only 5 flowers are blue. Okay, now what is our question? What is our question? There are two parts. It is a blue, it is not a blue. So, when you have flowers at random, now these are the flowers. Okay, you see these are the flowers and these are 385 and are mixed well. If you want to pick one and the probability, what is the probability that it is blue in color? It is very simple that probability of being blue probability of being blue is equal to how much are the flowers in this bag? These are 5 only. Okay, the total flowers are 385. 385. You can also divide it. And it will become 385 is equal to, now it is become 1 divided by 77. Now, since this is the probability of the blue, this is the probability of the blue, and if we want to find that it is not blue, it is not blue. P not blue, not blue is equal to 1 minus 1 upon 77. Okay, it is not blue, or other is also available to us. Other method is also available to us, but what we have learned is this format. The other format will be, yes, of course, there are 380 flowers. 380 flowers which are not blue. We know it from this data because only 385 flowers are there and 5 are blue. That means 380 flowers are. Uh, so we can do it like this also. Okay, but the format is like this, so we keep on doing it like this. So it will become how much? 1 minus 1 divided by 77. That will become 76 upon 77. Now this is our probability that the flower is not blue. The flower is not blue. 300, let me check it if it is correct. Yes, this is correct. But we have to show this format. We have to show this format. Okay, now uh, this was part A and this is part B of the same question. So question number 6 now. This was question number 5, part A, part B. These are two answers. Okay. And now question number 6. Question number 6 is a bag contains 9 equal size balls. 4 of them are colored blue, remaining balls are colored. Now there are how many? There is a bag in which there are how many balls equal size and equal weight, length, everything is equal. There are 9 balls. Okay, in which how many balls? 4 of balls are colored blue. 4 of the balls are colored blue. 4 balls are blue. 4 balls are blue in color. If these are balls, I know it. Blue. And of course, when these are 9 balls, then that means the 5 are red. If 2 color choices is given to you. Okay, now what is the question? Let me read. A bag contains 9 equal size balls. 4 of balls are colored blue. The remaining 5 balls are colored red. Red 5, blue 4, 9 balls in total. What is the probability when the ball is drawn from the bag? It is blue. It is blue. You see how many balls are there? There are 9 balls in total. And if you draw at random, P of B, blue, P of blue is equal to 4 upon 9. 4 upon 9. Because there are 4 balls available to you in the bag of 9 balls. So it will remain. And what is the B? B part is, it is red. Of course, if it is this, R is equal to, there are 5 balls. So 5 upon 9. Okay. So this is very simple questions. It is neither blue or red. It is neither blue or red. It is P is equal to neither B nor R. Okay, it is 0 upon 9 because there is no other choice available to you. There is no other choice available to you. Okay, no color other than blue and red is available to you. So the probability will remain 0. And this is the one example that probability will remain always from 0 to 1. And next is your part D, which is P, that it is either blue or red. Either blue or red. That is equal to 1. Okay? Because it is 9 upon 9. Because 9 upon 9. The probability is 9 upon 9. When you pick the ball, you don't know which ball you are going to pick. It will be either red or blue. It will be either red or blue. It is equal to 1. So this statement remains true, that the probability will remain from 0 to 1. From 0 to 1. Now question number 7. Okay, we have a very short lecture today and hope that we'll complete it in just 15 to 20 minutes, and then we'll start our worked example. Yes, we'll be doing one example after this. A bag contains 36 balls. The probability that ball drawn at random is blue. How many balls are there? Yes. Now now in a bag there are how many balls? Balls are equal to question number is 7. Question number is 7. Okay, balls are equal to 36. Okay, balls are equal to 36. The probability that the ball drawn at random is at random. At random, I can say at random. Okay, at random, probability is 1 by 4. For what? For what? That it is blue. That it is blue. That it is blue. Okay. Now probability at random is 1 by 4 that it is blue. Now what does it mean? That we have this probability 1 by 4. Then he says how many blue balls are there? Blue balls. Now we have to calculate the blue balls. Okay, equal to this. So the probability remains this. Okay, it is very fine. So when you have the probability 1 by 4 is equal to, then what does it mean? That the total probability is given to you, total number is given to you, just multiply it with this, it will become 3 times 9 blue balls are there. 9 blue balls are there. Let me check it out. I have not checked the answer so far, but I hope that the answers are correct. Yes, the answers are, all the answers are correct so far, from 4 to 7. Okay, now question number 8. Question number 8. All the answers are correct. Oliver shuffles a pack, no card. It is question number 8. Pack of card has come again. Playing cards. There are how many playing cards? I just told you in your previous lecture that there are 52 cards in a pack of cards. In a deck of cards, it's also said as a deck of card, a pack of cards. You can what so pack of cards. Pack of cards is equal to uh, 52 cards. Now, what is the probability? If he then draws a single card at random, he draws a single card. PS. Single card. That means single card is 1 by 52. Probability of single card 1 by 52, and 1 by 52 can be any card. 1 by 52 be any card. Now, what is the probability? Now, what is the probability? Now, question number A is, what is the probability that P is a king? Now, you see, I told you that there are 4 colors in a card. Okay, it is spade with black color. Just to recall you, spade with black color and club with black color. Club with black color. Both are black. So these are both black. These are red. It is heart and diamond. These are red in color. These are black in color. Now each color have a king. Now each color have a king in its formation, and the cards are from 0 to 10 are the numerical cards, and from 11 to 13 are the pictorial cards, in which each there is J, Jack, Queen, and King. 11, 12, 13. 11, 12, 13. The numerical number of these are 11, 12, and 13. But what we are concerned with, that each color have a king. Each color have a king. So when each color have a king, there are 4 kings. That means 4 out of 52 will be our probability. And if you simplify it, it will become 1 by 13. It will become 1 by 13. 4, 13 times is 52. Now B. Similarly, all the questions are like this. A spade. Well, yes, a spade is like this. This is a spade is equal to, since there are 13 spade cards. There are how many cards? 13. There are 13 spade cards out of 52. It does mean that it is 1 by 4. Okay? 1 by 4. And C, what is the C? A black card. P is equal to a black is equal to black are how many? 13 plus 13, 26 divided by 52. That means the probability will be 1 by 2. And D is, what is D? A prime numbered card. A prime number card. Now prime number. Now from 0 to 10, because these are factorial card and don't have a number on it. They don't have a number on it. And of course, there are 2 prime numbers in these, 11 and 13. 11 and 13. But pictorial card don't show the numbers on the on their card. Only Jack is up the picture over here, Queen is the picture over here, and King is the picture over here. But if you count in some games, it is counted as from. Now this is number 11, this is 12, and this is 13. Okay, but for our case, maybe let me take from 0 to 10. There are how many prime numbers from 0 to 10? Okay, now 2 is prime number, 3 is prime number, 5 is prime number, 7 is prime number. 1 is not prime number. I have already told you many times that 1 is not the prime number. 2, 3, 5, 7, 8, 9, 10. Okay. Now these four are the prime numbers. These four are the prime numbers. Now, how many prime numbers? 1, 2, 3, 4 multiplied by 4. 4 multiplied by 4 is 16. So it is equal to 16 upon 52. If you divide it with 4, it will become 4 times and 4 13 times. Now this is the probability that P is P. Okay, P is P. Okay, now you have completed. You see that he has taken only the numerical cards. He has taken only the numerical cards, not these cards. In some games, I am telling you that in some cases, in some games of the cards, it is taken as 11, 12, 13, but there is not the on the card, the numbers are not printed. Numbers are not printed. J, K, and Q. Numbers are not printed in any card from 11 to 13. Okay, now the example. Example of what? Example of what we are going to do is, okay, possibility diagram. The possibility space is the set of possible outcomes. Now, the possible outcomes as we have did here is, for example, we have a dice. We have a die, and there are how many numbers? You know that there are this number, and this number. Instead of dots, I have just written. And we have multiplied by 2 dice. Now, first we have the die, and then we have the dice. Die is singular, and dice is plural of the. Okay? When you roll 2 dice together, then what is the probability? Now you see that there are 6 faces now. 6 and 6, 12 faces now. Okay. Now there are 12 faces now. 12 faces now, and out of 12 faces, it is always a chance. It is always a chance that 2 faces will appear on the top. 2 faces will appear on the top because there are 2 dice. So 2 divided by 12. 2 divided by 12 will be the probability of each face. So what is the probability that it will be 1 on both? What is the probability that it is 2 on both? What is the probability that there is 1 and 2 on the board? Okay, now there are different probabilities and different outcomes. There are different probabilities and different outcomes of each and everything. Okay, now how will we manage these things? So let me. Now this is the uh, uh, topic which is called possibility diagram. Possibility diagram. Possibility diagram. Now, possibility diagram is what? Possibility diagram is a set of all possible outcomes. It is the space of a set of all possible diagrams. It can sometimes simplify our work if you draw a possibility diagram. Now, yes, you might have heard in our chapter of what was the chapter? I just don't remember the chapter name. It was, let me check it out. What was the chapter name? Yes, it was chapter number 4, you might have heard from me that there is a different combination of different things, and what we see is NCR. See this? So this will lead you, but for the time being, I'm not discussing it over here. Okay, because I think this is beyond your course so far. So let me uh, do it in simple way, and we have to draw a diagram in which all possible outcomes are there. All possible outcomes are there. See how it will be. Now two dice. Oh, the example is of again there. Two dice, one red and one blue, are thrown at the same time, or the number showing the dice is added together. Find the probability that the sum is 5, sum is less than 5, the sum is greater than 8, the sum is okay. Now there are two dice, and one is red and other is blue. One is red and other is blue. Okay, two dice. There are two. Okay, one is red and other is blue. So there are different things. If you roll together, obviously, if suppose there is one dot on one die, and let me say that there are three die on other, one, two, three. On other, the total is four. It is an even number. You can take it as even number. It is less than 5 also. It is less than 5 also. Now there are different probabilities. There is a chance of different probabilities, but we have to study what. Now we have to study that the sum is 7. The first we have to draw a table. First we have to draw a table in which there is like this. We have to plus it. Okay. Now of of course, this is the red column, this is the blue column. Okay, I can use the red marker also as well over here. 1 2 3 4 5 6, because there are six faces. There are six faces. 1 2 3 4 5 6. Okay, now there are six faces in blue as well. 1 2 3 4 5 6. Just make a grid of here. Let's make a grid, but not so very rough. Make it a little neat. Okay. Now here you can do it like this. Again, the vertical grid over here. Now you see, 1 plus 1 is 2 over here. Yes. And 1 plus 2, 3 over here. We are going to add these. 1 plus 4, 1 plus 3 is 4, and 1 plus 4 is 5, 1 plus 5 is 6, and 1 plus 6 is equal to 7. Okay. Now this table will continue from 2 plus 1 is equal to 3, 2 plus 2 is equal to 4, 2 plus 3 is equal to 5, and so forth. The table will carry out, and it will become like this. The last number will be 12. So you see that there are how many possibilities of adding? 1 2 3 4 5 6. 1 2 3 4 5 6. Now these are 36 possibilities. Now how many possibilities? There are 36 possibilities, and from the formula of this, you can also you can also calculate that this is equal to 36. Okay. Now our first question is the sum is 7. The sum is 7. Now how many sevens are there? You see, the sum is 7. If you see that there are, now this will be 7, 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 and this will be 7. Yes. 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7, 3 plus 4 is again 7, 2 plus 5 is 7, 1 plus. Now these are 6, 7. 1, 2, 3, 4, 5, 6. 6 in a grid, total number is 7. Now what it is, the sum is 7. The sum is 7. P 7. 7 because we are taking sum, you can say take it as sum is equal to 7. Okay, it is equal to 6 upon 36. It is 6 upon 36 and the probability will be 1 by 6. So this is the example. You can take any number less than 5, even number, odd number, prime number. You can take these, all these. So my dear students, uh, I leave this example for you to study and to do it on your notebooks, so you will understand it more easily. So it's time to say you goodbye. So take care. Allah Hafiz.